So now that we have kind of all of the tools that we need in order to start solving these kind of motion problems, these basic motion problems using differential calculus, it's about time that we actually go ahead and do that. And before we do, I just want to make a small clarification from the previous video where we were interpreting motion graphs. Over here, where the acceleration is less than 0, because of the fact that the function is positive, that means that we're still moving forward in the forward direction, but our velocity is decreasing. Meanwhile, if we take this point over here, or not this point actually, let's take this point. This point over here where our tangent line, or the slope of our tangent line, is negative, but the function is also negative, that means that we are moving, or we're increasing our velocity, but in the negative direction. So we're moving backwards and we're increasing our velocity in the negative direction. So that's kind of just a small clarification I wanted to make from the previous video. Anyways, let's go ahead and actually solve some motion problems now. So we're given x of t, which is this, lovely function right over here. And we want to find the acceleration and velocity at time t equals 1. So let's go ahead and do that. So first of all, we know that the velocity is given by x prime of t, right? Or actually, sometimes you'll see it represented in physics as x dot of t. So I'm going to actually go ahead and use that for fun. So that's going to be equal to the velocity of t, right? Or v of t. And essentially, we just need to take the derivative of this, which is just a very simple function. So the derivative of t cubed is 3t squared. The derivative of natural log of t is 1 over t. And the derivative of negative 7t squared is negative 14t. And if this looks kind of very foreign and arbitrary, then just keep in mind that this is kind of just coming out of our basic principles of the power rule, the kind of derivative of logarithmic functions, etc. So we want to find the velocity at t equals 1, so let's go ahead and input x dot of 1, which is going to be equal to, 3 times 1 squared, right? Plus 1 over 1 minus 14 times 1, which is just going to be equal to 3 plus 1 minus 14, which is going to be 4 minus 14, which is negative 10, and our unit is meters per second, or I guess SI unit would be meters per second. So it seems as though we're moving with a negative velocity at that point. And then if we want to find the acceleration, we can just take the second derivative of time, or of position with respect to time, which would be x double dot of t, or x double prime, or we could just write this as v dot, or v prime of t, which if we're going to take this derivative, again, this is going to be 3t squared. The derivative of that is going to be, we can bring this 2 down here, we'll end up with 6t. And then the derivative of 1 over t, we can rewrite that as t to the negative 1, and then take the derivative like that. We'll end up with negative 1 over t squared. I encourage you to try this out for yourself, by the way, to kind of gain more practice on taking derivatives. And then negative 14t, very simple. The derivative of that is just going to be negative 14. And so if we want to find x double dot of 1, then that's going to be equal to 6 times 1 minus 1 over 1 squared minus 14, which is going to be 6 minus 1 minus 14, which is equal to 6 minus 15, which is going to be negative 9 meters per second squared. That will be our unit, assuming we're in SI units. So that's our final answer. That's essentially all that we need. We have this answer and we have this answer. So as you can see, solving motion problems are really not that bad when it comes to using calculus. It's actually quite simple. And let's actually go ahead and do one final example over here. We're given the velocity as a function of time, v of t. It's given by this lovely expression over here. And the acceleration, or they're asking for the acceleration at time t equals 0. So this is kind of the initial acceleration, if you will. So we know that we can go ahead and take the derivative of velocity with respect to time, and that will give us the acceleration, right? So that's going to be equal to a of t. What is the derivative of arctangent of x, or arctangent of t, or whatever? Well, if you recall, that's just 1 over 1 plus t squared. Is that correct? Yeah, okay. And then the derivative of negative 3 e to the t, we know that the derivative of e to the x is just e to the x. So negative 3 e to the t is just going to be negative 3 e to the t. It's going to remain the same when we take the derivative. So at time t equals 0, let's actually go ahead and input that. We're going to put a of 0, which is equal to v dot of 0. And that's going to be 1 over, essentially 1 plus 0 squared, so just 1 over 1, minus 3 e to the 0. We know that e to the 0 is just 1. So it's going to be equal to 1 minus 3, which is negative 2 meters per second squared. And that would be your final answer right over there.